All right, so our goal for today we're starting Unit 4. Unit 4 is linear system still, so we're going to be doing substitution and elimination. So that has not changed from Unit 3, but now instead of doing them in 2 variables using x and y, we're going to be doing them in 3 variables in x, y, and z. So we are adding on to what we did last unit. Okay. We're also going to be talking about matrices. Okay, that's something new. So that's Unit 4. So that's what this new packet is. Lesson 1 are graphs in 3 dimensions, because if we're going to be working in x, y, and z, we need to figure out what does this look like first. Okay, so our goal for today is to graph points and equations in 3D. So we've been working in 2 dimensions. That's the old stuff. We would graph what we call ordered pairs. Or sometimes we'd call it a coordinate point. And when we plot them in what we call the coordinate plane. Planes are 2D. They're flat. The axes, what were your axes called? What were your 2 axes that you had? The x-axis and the y-axis, so we had 2 of them. Okay. And they were the x and the y-axis. So our point looks like x comma y. In 3 dimensions, they're no longer going to be an ordered pair. They're going to be an ordered triple. And when we plot them in what we call the coordinate space. Because if we add a 3rd dimension, we're no longer working on a flat surface. We have space. We have 3 axes now. We'll still have the x-axis and the y-axis, but we'll now add in the z-axis. So, we are going to talk about how to describe the location based on these points. So, previously, so you don't have to write this down, but if I gave you the point 1, 4, how would I get to this point 1, 4? Go to 1 on the x, and then you go up to 4 on the y. So this one would go right 1, up 4. That's how I'd get there. Is that okay? Okay, if I went -3, -7, how would those ones move? Your x goes left and right. So we're going to go left 3, then down 7. Okay, so that was before. Now all of a sudden we have 3 numbers to look at. So the first number tells you how far forward and back. So if you look at these axes down here, this actually shows you your x-axis moves forward or backward. Okay, so this direction is forward. This direction is back or backward. This direction, so now it's different because your y is now in the middle of your point, but your y is going to be the one that moves to the right or to the left. And your z-axis is what goes up versus down. And it might be easy to see because we'll make sure that that's marked as z there. So now we have our x is marked forward and back, our y is marked left and right, and our z is marked up and down. So if we look at this first point, it's in order, X, Y, Z. Okay, so let's talk about the positive versus negative. Forward is positive, backward is negative. Okay, the right is still positive. These ones haven't changed. You still can move left to right, up and down. Right's positive, left is negative. Up is positive, down is negative. So, when we're looking at this, we have X, comma, Y, comma, Z. So our X is 2. So we have to describe the location of this. So if X is 2, that's the blue, it moves forward and back. 2, is it going to move forward 2 or back 2? Forward, because that's where the positive is. So it's going to move 2 forward, or forward 2, I don't care how you say it. So 2 forward. The Y, the middle, 3, is going to move left or right. The 3 moves which way? To the right, because it's positive, so 3 right. 3 units right. And then the Z, which moves up and down, is a 4. So does that one go 4 up or 4 down? 4 up. And that's how you would describe it. You just have to tell me how far forward, how far left or right, how far up or down. So far, so good? Let's try the next one. So the 0 tells you what? Which direction? Forward and back. The first number is forward and back. So you move 0, and it doesn't really matter here if you say forward or backward, because you're not moving forward or backward. So you can say 0 forward or 0 backward. It does not matter. The Y is 1. What does that tell you?
Left to right.
Left to right. So how far does this one move? It moves 1 which way? Right, because it's positive. And the last number is a -5.
You go
Down 5. So 5 down. Go ahead and try the last one on your own. Try C on your own. So this one moves 3 backward. It moves 2 left and 4 down.
So you don't want to put like the negative, you just want to put...
No, you do not want to put the negative, because then you're going to be, it's a double negative, so then you'd be saying you'd be going 3 forward. If you went -3 backward, you'd be saying 3 forward. Does that make sense? So yes, just put the positive number, so 3 backward, 2 left, 4 down. You're just talking about a distance, so you want to know the distance that it traveled. The direction covers if it was positive or negative. Okay, so then it says to write the coordinate of each point. Okay, so they only plotted, they did a whole box here, so you could see what the point, where the point was located. But the point that they're actually referring to right here is the only point that is on the actual box. Do you see how they have a point right here and nowhere else? They are plotting that point. That means that this has an ordered triple. Okay, and the X will tell us how far forward that point is. So how far forward does this point go? So if you were to go to this point and travel back to the x-axis, where on the x-axis does it hit? How far is that front plane forward? 1, 2, 3. So we went 3 forward. Is forward positive or negative? positive. So we're going to mark this as a positive 3. Okay. That middle is our left and right. That's the y. So if we look at this plane that point is on, that left plane, how far left does that plane hit? 1, 2, 3, 4 to the left. So left, is that going to be positive or negative? Negative. So we're going to write a negative 4 for our y. The z-axis is how tall is that point. So this top plane is how tall it is. How tall is it on that z-axis? At 2. So we're going to have a 2 for our z coordinate. Try and do this next one on your own. We'll label it. Your z is already labeled, but remember, up is positive, down is negative. Your y is labeled, but this way is negative, this way is positive. Your x has a label. This way is positive, this way is negative. So try to figure out what would your coordinate be. X, comma, y, comma, z. All right, what are we finding for this one? What is your x coordinate? Negative 1. Good. We have to go back 1. Okay, I'll highlight that point they're talking about. They're talking about this point here. So we have to go back 1. So that's a negative 1. Okay, and then how far left or right do we go?
2.
You're going 2 to the right. So that's a positive 2. How far up or down do we go? 2. Now you'll notice that this up 2, you want to look at that top plane. Where does it hit on that z-axis? Right? So your z-axis is going up 2. Up is positive, so positive 2. Okay. Next, I'm going to show you how to plot that point. So you flip it over. It's much easier to plot it if we describe where that point is moving first. So, how does this point move? Back 4. Then what? What's that middle one tell us? Left 4. And what does this 3 tell us? Up 3. So what we're going to have to do is, first off, we need to make sure that our scales actually go to 3. So our x, this is x, this is y, and this is z. We need to make sure that our scales on our graph actually go to those numbers. So on our x scale, remember this way is positive, this way is negative, so this would be 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I'm just going to label on my axis, yes?
Why wouldn't they make the z-axis like the same as it used to be, the x and y, and then make their new axes?
Because math wants to be difficult. Yes.
Well, it just makes up the whole operation.
I know, but the thing is I'm always going to give you axes that are already labeled, so they show you where x, y, and z all are at. So hopefully that will help you guys some. All right, so y is going left to right, so we have negative 1, negative 2, negative 3, negative 4, 1, 2, 3, and 4. That'll work for those. Z, we only have to go up to 3, so 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. There are some on your assignment where you may have to change the scales from 1. You might have to go up by 2s or go up by 3s, depending on what you're trying to plot. So, when we go to graph this, we're going to go back 4. So we're going back to that -4 there. Okay, that's our first step. Then we're going to go to the left 4. Well, when you go to the left 4, or go to the y-axis, and look for -4, we're right here. So what we're going to start with is creating like the bottom or the top of this box. Okay, and it's easiest if you go to both of those and then meet them, creating a parallelogram. So keep this parallel to the y-axis, keep this one parallel to that x-axis. Does that make sense? So you're drawing that parallelogram in there, and that'll either be the bottom or the top of our box, depending on if our box is up or if our box is down. Now this box is up. It's going up 3. So that's that front line of your box. And then you can draw in the rest of your parallelograms here, creating that box. So there's the side of our box. Okay. This front rectangle is going to be the front of our box. Okay. Went a little too far on that one. There we go. That's the top of our box now. And I still have a vertical to connect over here, which is that back corner of the box. I can erase this extra line in there too. There's our box, but which point are we actually referring to? Well, if I take and I go backward 4, left 4, up 3, the point I'm referring to is this corner right here of the box. So I'm going to make sure that I actually put that as my point when I'm drawing this in. Okay. So if you go to assignment 1, we're going to skip the equation part of this for right now. Okay, I'm going to give you guys some time to work on the actual assignment. If you go to the assignment, you can now complete numbers 1, 2, and 3. Okay, those are just describing the location. So tell me, how far forward or back does it go? How far left or right does it go? How far up or down does it go? For 4, 5, and 6, you're going to graph just like we did on this one right here. Okay, so you're working on drawing that box and then identifying where that point is. For 7 through 12, you're going to use this picture. Okay, use this picture to locate where A is. Okay, A is right here, which appears it's where the X, Y, and Z axis all meet. Okay, might be kind of hard to see, but they have it labeled that this is your Z axis. This here is your Y axis. And this here is your X axis. And then they have scales, 20, 40, 60, 80. Here's 40 and 80, so that's 60 and 20. Here's your Z axis. Here's 40, 20, 60, there's 80, 100. So you should be able to label the X, Y, and the Z axis. Once you have the X, Y, and the Z axis, where is A located? Where is it on the X, the Y, and the Z? Okay, so it gives you a 3D image that you're finding the locations, kind of like the box ones. And then don't work on the back yet, so just work on finishing the front of this. And then we'll work on the notes a little bit more, and then we'll move on to the back. All right, so you should have gone through and been able to do the entire first page of assignment number 1. And now what we're going to do is we're going to work on sketching a graph of an equation in 3 dimensions. Okay. When we would graph on a coordinate plane, so using just like y equals 3x plus 4, what did our graph look like? We graphed on a plane, and our graph was a... Was it what?
It was flat.
It was flat, okay. Like y equals 3x plus 4. How would I have graphed? Here's my x-axis, y-axis. There we go. And I have to graph y equals 3x plus 4. What would I have done?
Go up 4 on the y-axis.
Go up 4 on the y-axis. Sure. Let's say it's there. And then what?
You go up 3 and then right 1.
Up 3, right 1. And I'd put a bunch of points. And then what would I do once I had all these points? I put a line through it. So when I graph on a coordinate plane, my graph of this equation was a line. Right? When we graph on the plane, it becomes a line. Okay? So if I'm graphing in 3 dimensions, what's a line going to become now? A plane. Yeah. So that line is just now in 3D, becomes a plane. Are you with me? Okay, so our first step when we are graphing, that's not what I was looking for. The 3 dimensions are, we are going to have to find all 3 intercepts. So before, we had 2 intercepts because it was a line, but now because it's in the 3D space, we're going to have 3 intercepts because there are 3 axes to intercept. Okay? So we need to find all 3 intercepts is going to be step 1. And we'll put that information that we just talked about. If we're graphing in 2D and we're graphing an equation, it's a line. But if it's 3D and we graph an equation, it becomes a plane. And if you remember back from geometry, what is a plane? What's a plane? What's it look like? Or maybe an example from the room. Yeah, the desk surface is a plane. Right? The floor would be an example of a plane. A piece of paper would be an example of a plane. Okay? It's a flat surface. That extends in all directions. So even though, yes, the floor of the room eventually ends, you're going to, as a plane, we would imagine that it goes forever in that direction, and goes forever in this direction, and goes forever that direction. It goes forever outside of the room as well. It's part of this plane. Can you kind of visualize what that would be? So the first step is we're going to find all 3 intercepts. And then we're going to plot those 3 intercepts. So you find them, you plot them, and then you're going to connect them in order to see the plane. So, the first thing that we're going to do here is we are going to find the x-intercept. Now, the x-intercept is going to be x, 0, 0. The x will be a number, everything else will be zeros. So, in order to find that, what we're going to do is we're going to use our equation up here. We don't know what x is, so we'll leave it what x is. And then we know that y is 0, so plus 4 times 0, plus 2 times our z is 0, equals 12. And now we're going to have to solve. What's 4 times 0?
0.
So we have 3x plus 0. What's 2 times 0? So plus 0 equals 12. What's 3x plus 0 plus 0?
3x.
Just 3x. When you add nothing to it, it doesn't change. So 3x equals 12. What does x have to be then?
12.
4. So that tells us that this point is 4, 0, 0. Okay. Now the nice thing about plotting these points are that they're always on an axis. So our x-axis moves forward and back. If I go up by ones, 1, 2, 3, 4, -1, -2, -3, -4, I can see that 4 is right here on the x-axis. I don't move left or right or up or down, so I'm just plotting that point right on the x-axis. Now we're going to do the same thing, but this time with the y-intercept. What's the y-intercept going to look like as a point? If this one was x, 0, 0, what would our y-intercept look like?
0, y, 0.
Very good. All right, so we're going to have to go to finding this one. So we're going to plug in the zeros again. So 3 times our x is now 0, plus 4 times our y, which we don't know, plus 2 times our z is 0, equals 12.
Oh, that got to be 3.
It has to be 3. This is going to turn into 0, and that's going to turn into 0. So 4 times what number gets you 12? Y is 3. So you can see you don't have to do a ton of work every time. If you want to skip filling all of this stuff out, if you can look at it and say, okay, 3 times, use the cover-up method. 3 times what number gets you 12? X would have to be 4, so 4, 0, 0 is one of your point. Cover up your y and your z. 4 times what would y have to be to get you 12? So 0, 3, 0 is this point here.
So the next one would be like 6?
Well, let's look. So our z-intercept has to be 0, 0, z. Right? So cover up your x and your y in there. 2 times what would your z have to be to get you 12? 2 times 6 gets you 12. So it is 0, 0, 6. Okay. Now, going back up to the y-intercept because we haven't plotted that one yet. I'm going to have to plot 3, so if I go up by ones, I'll be fine there. Hits it at 3, so I'm going to make sure to put a point at 3. You got to warn me when I'm not writing on the paper. There we go. Okay. Now your z, if you go up by ones, 1, 2, 3, 4, we're not going to make it to 6. So you're going to have to change your scale here. Maybe go up by 2s or 3s. So I'd make this 2, 4, 6, 8, -2, -4, -6, -8. So I would change one of my scales to make sure I could plot. The z-intercept hits at 6. Okay. Once you have those 3 points, this is going to help you decide where the plane is going to be. It's going to allow you to see that because you have to connect the 3 points. So what you're going to do is you're going to put a line that extends in both directions through those 2. You're going to put a line, so use your note card that I gave you guys a couple weeks ago. That should be your straight edge. Line that connects forever in those directions. Connect the last 2. So you're creating 3 different lines here. Okay. And then this will allow us to see the plane, and we're going to shade the plane so that we can see it even better. And so that we can see what is this equation we're actually graphing. It's this triangular looking plane that, yes, we have to make sure to extend the lines to show that this plane keeps extending in all those directions, but there's a part of that plane. Okay. Now that we've done this, you should be able to do the back of that assignment number 1. Okay, assignment number 1 is due before you leave.